Okay, so today we're going to talk about how to find the equivalent resistance or total resistance of a circuit that is not just series or just parallel, but has components of both. So let's go ahead and look at circuit A on the left first. So if you look, this circuit go ahead and it starts as just a series circuit. There's only one way for that current to flow, and then it transitions to, there are three pathways for it to flow, so then it transitions to parallel. Okay, so since this circuit just starts initially as a series circuit, we are going to redraw it as a series circuit to help us in our solving. So it starts as a series circuit, and for something to start as a series or parallel, it needs to have a resistor there. So we have 3 ohm resistor right there as a series. Now it splits into, this component is a parallel part, the 4 ohm, 6 ohm, and 8 ohm together. So we're going to need to find that equivalent resistance of that part. We know that it's parallel, so we're going to go ahead and use the rules for a parallel circuit. So we know that this R equivalent for this parallel section is going to be 1 over 4 plus 1 over 6 plus 1 over 8. Okay, and I went ahead and just put these in my calculator, but when I add up all these fractions, and you can use common denominator, which is probably even better than what I'm doing, I'm just plugging it in, I get 0.54 equals 1 over R equivalent. So now I need to solve for R equivalent. To solve for it, it needs to be up top. So I am going to go ahead and multiply both sides by R equivalent, and then it cancels on the left. So we got 1 equals 0.45 R equivalent. Our last little step, we can divide by 0.54 to get R equivalent. So then I got R equivalent to be 1.85 ohms. Okay, so now these 3 resistors, the 4, 6, and 8, I found that the total for that is going to be 1.85 ohms. So I'm going to rewrite it as I said 1.88, it should be 1.85, as 1.85 ohms. So now if I look at this circuit, it's now just straight. There's only one pathway for the current to flow. So this is a series circuit. So I know how to find the total resistance for a series circuit. I just go ahead and add them up. So our total is going to be just 3 plus 1.85, and that is going to be 4.85. And so that is going to be the equivalent resistance of this circuit. Okay, we're going to go ahead and do example B now. But we'll go ahead and make sure that write this down, and I'll erase the screen and restart for B. Okay, let's go ahead and look at B and think about what type of circuit this is. So if you go in B, again, we'll start with the dots. So we start right here. There's no resistor here, so it's not in series to start. But the current all of a sudden splits here and goes down 3 different pathways. So we're going to need to redraw this circuit as a parallel circuit since it starts as a parallel. Okay, so now let's go ahead and look at each branch. So on the right-hand branch, there's just one resistor. So the 4 ohm, we can ignore that. 1 ohm, or just leave it there for now. Okay. But this one, the 2 and 3, there are 2 resistors right there. Those 2 look like they are series to each other because there's only one pathway for it to flow. So we are going to combine those together, and we know that those 2 together are going to be 5 ohms. Now we're going to go ahead and redraw the circuit because we had just simplified it. So if we redraw this circuit, we have a 5 ohm right here, and then the 1 ohm stays, and then the 4 ohm stays as well. Oopsies, that was a horrible redrawing. Okay, there we go. That's a little bit better. Okay, so now if we look at the circuit for B, there's just one resistor in each pathway, and the current just splits at the beginning. So this is just a parallel circuit, so we can use the rules for parallel circuit to find the total resistance. So I'll go ahead and do that up here. So 1 over R equivalent is going to be 1 over 5 plus what? 1 over 1 plus 1 over 4. Okay, and when I plug that in my calculator, I get that to be 1.45 is 1 over R equivalent. So then I can do 1 divided by 1.45, and I get 0.69 as the resistance. So that is the equivalent resistance of circuit B, and I should include my units. That's 0.69 ohms, or you can use the symbol omega. Okay, so let's go ahead and do one more together, just for a little more practice. I encourage you to try C on your own first, and then check back on the video to see if you got it right. Okay, so again, to start this circuit, we go ahead and start at one end, and I would start at the end where there's like a resistor initially. So I'm going to start at this little X right here. So the current is initially going to go through this 5 ohm resistor. How many pathways are there for the current to flow? Only one. So we know that we're going to redraw this circuit as a series circuit. So I'm just going to go ahead and start by doing that now. So we know there's just going to be one 5 ohm resistor at the beginning. Okay, so let's go ahead and look what's next. Then we get to here, the current splits. So it becomes a parallel circuit. So next we're going to need to redraw this part on the right. So this whole entire part, we're going to need to redraw that as a parallel circuit because that's what it next is. So now let's look at each pathway. So the 4 ohm, there's only one resistor there, so that can just stay. But the 2 and 6 ohm, there are 2 pathways for that current to go through. Or sorry, there is one pathway right there for the 2 and 6 ohm to go through. So the 2 and 6 are in series to each other. So we're going to need to redraw, kind of like we're starting at the very end now. We're going to need to redraw those two as series together. So let's go ahead and just keep that 4 ohm resistor as is. And then we can combine the 2 and 6 ohm, which those are just 8 ohms together. And then we have it redrawn so far. Okay, so now let's go ahead and look at this. This circuit is not just series or just parallel, but it has some components of both. Because again, current starts here, it starts in a series, so we're going to have to redraw it as series at the end. And then the current, when we get to this junction, it splits. Some goes down the 4 ohm and some goes down the 8 ohm. So we know the 4 and 8, those two are, since the current splits, those two are in parallel to each other. So we're going to have to find out the resistance of those two. So we're going to go ahead and use our rules for parallel circuits. So 1 over R equivalent is 1 over 4 plus 1 over 8. I'll do this one with common denominators. So this is what 1 over R equivalent is, what's that, 2 over 8 plus 1 over 8. So that is going to be 3 over 8 equals 1 over R equivalent. I can go ahead and cross multiply. So I got 8 equals 3 R equivalent. So 8/3 is going to be R equivalent. Great. So the 4 ohm and 8 ohm together are going to be essentially 8/3 ohms. So I'm going to go ahead and redraw the circuit now. So we have a 5 ohm just initially all by itself. And the 4 and 8 recombine to be 8/3 ohms. Okay. So now we have that redrawn. Okay, so now if we look at this circuit, so some current goes through here, or all of the current just goes through here because there's only one pathway, all goes through the 8/3 because there's only one pathway, and all goes here. So you know what? I can just use my rules for series circuit and add them together. Okay, so R equivalent is just going to be the 5 ohm plus 8/3 ohm because we can just use our rules for series. I'll just keep on doing the fun fractions. So 5 ohms is going to be what? 15 over 3 plus this is going to be 8 over 3. And that is going to be, what is that? 23 over 3 ohms, which will simplify to, and that will simplify to 7.67 ohms. Great, and that is equivalent resistance for this circuit. Awesome. So if you have any questions, feel free to write them in the comments. I want to go ahead and just give you the answer for this one, just so you can have practice with it for D. But the answer to D right here is 11.18 ohms. And again, feel free to try it yourself and let me know if you have any questions on D. Awesome. Thanks for watching.